Assalamu alaikum, dear students. Today we are going to discuss the vertical circular motion, which is the last topic of chapter 12, motion in a circle of A2 physics. Here we have to consider a body which is moving in a circle. Like suppose this is the diagram we can consider here, and you can see that when the body is moving into the circumference of a circle, then there are certain forces acting on the body, and at each and every point we can consider these forces. But if we do not have any special propulsion, then the speed of course will decrease when you will move upward, and when you are coming back towards the bottom of the vertical circle, then the speed will increase. So this is what we have as far as the basic point is concerned. Then, as I said, that at different points we can mention the forces, and these forces here are basically two main forces. One is the weight of the body, mg, and another one is the normal reaction. So if you have a sort of carriage like in amusement park, you have the mass of the carriage as m, and it is moving in a vertical loop, then simply you can say that the situation is that at certain points we can mention the forces, and I have taken 4 points where we can consider these forces. Like at the bottom somewhere here, you can say and see that the difference of your normal force, contact force, and the weight is giving you the centripetal force. And if you want to write the normal force, then of course you can change this equation into N1 is equal to Fc1 plus mg. So this is what we have as far as the bottom position of the body is concerned. When the body is moving upward, so I have taken this point at the highest point or the top of this circle. So at the top of this circle we have again the centripetal force, which is towards the center of the circle, which is we have taken as Fc3. And in this case both the forces, like here you have one force as the contact force and another force is the weight. So both of these forces are acting downwards. So simply you can say that the situation is that we have in this case centripetal force, which is equal to your this situation. And centripetal force will be equal to N3 plus mg. And if you want to mention over here that what is the normal reaction, so simply you can say that this is centripetal force minus mg. For the rest of these two positions, any position 2 and position 4 here, you can see that the weight is acting downwards and the normal contact force or reaction force is toward the center. So simply we can say that for in both these positions, the centripetal force is nothing but the normal reaction. So these two equations are just giving us these positions, position 2 and 4. And as I said that for position 1 and 2, we have these forces in a centripetal force over here at the bottom, and in this case at the top you will have different equations. Now the thing is that when as the carriage goes around, the magnitude of the normal force changes because the speed changes, as we have just discussed that the speed is decreasing when you are moving up and is increasing when you are moving down. So the weight of course it has different effect at these two different points, and ultimately the centripetal force is also different. Now we want to know that what should be or what will be the minimum speed at the top of the circle to remain on the track. Simply as we have just considered the equation at the top of the circle, so we are just considering here that the carriage must have a minimum speed at the top of the circle to remain on the track. So this is very important, to remain on the track. So if we have this equation, then simply you know that the centripetal force is mv square over r. If we are considering, then there is no contact force, yani contact force is 0, then the equation will be simplified in this way, that mv minimum square divided by r is equal to mg. So this is what we have, and in this way we are basically calculating the minimum speed which is required for a body to move in a vertical circle. And if you will have this value, like suppose this is the situation of your velocity, initial velocity, but the point is that if you have a velocity which is less than that, so you can go somewhere here, yani you can fall and you cannot maintain your motion into a vertical circle. So this is very, very important, that to move in a vertical circle we need a minimum speed. So this is very important, and otherwise what will happen, you will fall, because if the speed will be less than that, what will happen, you will have this type of situation, that the body is going in a you can say smaller radius, you can say, and the body will fall towards the center. So this is something which is very important to know, that when we are moving in a vertical circle, we have to consider, or we have to have a particular velocity. So this is important. On the other hand, we have certain other examples as well, like for a metal sphere swing in a vertical circle at the end of the cord, and you have something like this. At the end of the cord you have here a body, and you are just rotating this body, then this will be a vertical circle, and in this case the tension in the cord will basically give you the centripetal force, and ultimately you can say that the weight is downward, and of course the tension is also downward. So forces you can determine with the help of the same sort of situation as we have discussed in these cases. Then for an aircraft looping the loop, the lift on the aircraft wings is equivalent to the normal force in the previous example, yani as we have considered here the normal force. In this case, in case of the aircraft which is looping the loop, what will happen, the uplift or lift on the aircraft wings will provide us that normal force, or you can say that the forces acting on the aircraft will be the lift and the weight of the aircraft which is downward. So this is another example you can say. Then here we have another situation where we have a body, where we have a vehicle at the top of the hill. So what is the situation here? So let us consider a vehicle of mass m. This is the mass vehicle over here. The mass of the vehicle is m. So simply you can say that the weight of the vehicle will be mg, and it is moving at a speed v along a road that passes over the top of a hill or over the top of the carriage. And here you have a sort of hill or you curved bridge, and the vehicle is moving with velocity v. So what will happen, again we have to consider that what is the situation of your normal force, as in this case we are considering, and weight is here. At the top of the hill, the normal force from the road on the vehicle is directly upward in the opposite direction of its weight, as we have discussed in the previous example as well. But in this case, at the top, the normal and the weight both are acting downwards, but when the body will be somewhere here at the top, the situation will be different, because in this case the normal will be upward and the weight will be downward. And in this example we have the same situation, and the weight is of course downward force, and over here we have the normal reaction. So this is what we have. So what will happen in this case, the resultant force on the vehicle is the difference between these two forces, and of course this resultant force will be the centripetal force. And what we can write here, that mg minus s is equal to mv square over r. So be careful when you have a situation like this, then both these normal reaction and you can say here you have the body, so the weight and the normal reaction or contact force is in the same direction, and the addition of these two will give you the result, which is the centripetal force. But in this case there is a difference, and the difference of the forces, you can say we are just mentioning here, and this is something mg minus n is equal to mb square over r, or we can write that here basically this s is nothing but n, so either you are writing n or s, doesn't make any difference, but this is basically the normal force. So when again normal force is 0, then the velocity will be again square root rg. So again this is the minimum velocity with the help of which you can say the body can move easily along this track, the curved path. But if the velocity increases, what will happen? You can say that the body will not remain on the track and it will leave the track. Here I just want to show you one sort of animation, and this animation is something which showing you that what is happening. Like this case, you can say that the speed is 60 kilometers per hour. Here as soon as you will get 70 kilometer per hour or 80 kilometer per hour, you can see that the car is leaving the track. Look at this animation again. Here you have the situation, 60 meter per second is okay, but as soon as you will increase the speed to 70 or of course more than 70, the car will not be on the track and it will leave the track. And this is something which is very important to understand, that if you are moving on the top or over the top of the track, then you will have a certain minimum velocity. Beyond this velocity, the problem will be that the car or the vehicle will not be in contact with the road. So this is very, very important, that the acceleration of course at the top of the track is a, which is of course toward the center of the circle. But as I said that you will have in this case a minimum speed, and you should know that if you are going beyond that speed, you cannot be on the track. So there are so many examples where we can consider the situation of your vertical circle. Like here, suppose you have a situation of loop the loop, then again you have to consider that what will be the weight and normal reaction and how you can move in this or in this track. So this is something which is very important. Like in roller coaster and other amusement park, you can say situations, we can see this vertical motion, and this is basically again the centripetal force and normal reaction, which is very important, and of course the weight of the vehicle or weight of the body. So this is something which is for your vertical motion, and this is the end of this chapter. Inshallah, we will try to go to the next chapter very soon. And if you are new on my channel, subscribe my channel, press the bell icon and share, and like this you can say lecture if you are getting something from this lecture. And if you will subscribe, then of course new lectures which I will upload, you can see and you can complete your course using this YouTube channel. So this YouTube channel will be helpful for you if you are following each and every lecture which I will upload time to time, inshallah. And best of luck for your A2 till the next chapter. Allah Hafiz.